afternoon, wherever you are in the world. Welcome to the 17th version of the Bitcoin Cash developers meeting for 2019. I'd like to introduce you, starting on my left, Tobias.
So I'm Tobias Ruck. I'm the developer of SLP DEX and Be.Cash and some smart contract stuff.
Great. Thank you, Tobias. Matias.
Hello, everyone. I'm Matias Garcia. I'm from BitPay. I work mostly on the wallet stuff and the open source stack.
Great. Thank you, Matias. Next, I have Jason B. Cox.
Hi, I'm Jason Cox, a software engineer contributing to Bitcoin ABC.
And then we have Antony Zegers.
Yeah, I'm Antony, also with Bitcoin ABC.
Great, thank you. And Jason D.
I'm Jason Dreyzehner. I'm working on BitAuth.com.
Great, thank you, Jason. Josh Green. Oh, we don't have your mic. Sound is not there. Okay, we'll give you a couple of seconds to get set up. I'll move on to Andrea.
Hi everybody, I'm Andrea Suisani, Bitcoin Unlimited developer.
Great, thank you, Andrea. And then Chris Pacia.
Hi, I'm Chris from work on BCHD.
Great, thank you, Chris. And we'll just
Does it work yet? Does it work?
Yes, we have your.
Okay, good.
Okay,
All
good.
Right. I'm Josh Green, lead developer of Bitcoin Verde.
Okay, and you're working on another project, and we'll talk about that a little bit later in the meeting. So we'll go from there. So I thought we'd start with the, according to the agenda, we'll start with an upgrade debrief. This is the first meeting after the recent network upgrade. Does anybody want to comment on the issues? Maybe we'll just go around from, maybe start with you, Jason B. Cox.
I'm sorry, what are we commenting on? The agenda or?
No, the an upgrade debrief. We're going to debrief on the
okay. Yeah, sure.
Recent upgrade.
Yeah, so as you guys know, the upgrade went pretty well. For most people, it went by pretty smooth, nothing too unexpected. We did gain some of our learnings of our own. That we did have a couple gaps in our own testing, so we figured out how to fix those, and we're working on something to make sure that those are fixed going forward for future upgrades as well. Nothing too crazy though. I hope future upgrades go this smoothly.
Okay. Considerably different than it was a year ago.
Yes.
Anybody else want to comment on the upgrade?
Yeah, I mean, we didn't have any issues on mainnet, but a BCHD did choke on a transaction that Mark made on testnet, which was it exercised like a very extreme edge case in the new check multi-sig code that wasn't exercised by the test vectors, but it was maybe an edge case that was just related to BCHD and not necessarily the spec, but nonetheless, it caused it to validate incorrectly, and so we had to put out a new release that fixed that. Yeah, so that was shortly after we fixed that.
Great. Thanks, Chris. Appreciate that. Anyone else want to comment? Andrea, do you have any comments on the upgrade?
Well, nothing particularly worthy to add. Everything went smoothly, also for EU. So that's being a good upgrade.
Anyone have any comments or on issues or things that might be improved for next times, or lessons that were learned aside from what's been stated?
So there has been a miner, Mark Lundberg, tweeted a bit about that, who mined blocks that were like from the old chain. Maybe we could, for the next upgrade, get a bit more in touch with miners to be more sure they upgrade. But I'm not sure if that's important because they just like wasted their own resources for being careless. But yeah, I'm not sure if there can be done a lot about that.
Yeah, so almost every upgrade, someone somewhere says we should get in touch with miners more to help avoid these. And the reality is that like miners come and go. Like the same miners that were around a year ago are not necessarily the same ones that are around today. And we try to chat with the ones that want to talk to us, but the reality is we can't keep track of everyone, and it's not even really our job to do so. So if someone's not paying attention and it costs them money, it's unfortunate, but that's the reality.
Yeah, I mean, I guess my comment on that is like, yeah, we do actually put quite a lot of effort into trying to contact miners. So I agree that that's like an important thing to do, but it seems like there's always someone who knows, either we don't know who it is or someone who, like in this case, it's like unclear exactly who that was. But yeah, I think we should probably, like what I would say is we should definitely like assume that there might be someone who doesn't upgrade. So we want to make sure that doesn't disrupt anything else. So in this case, it was basically didn't affect any, like they were completely incompatible with the rest of the network. Like I think BitMEX did a thing on that where it showed that, like the non-upgraded wouldn't follow the upgraded and vice versa. So I guess just something to keep in mind that there's a good chance, even though we do put a lot of effort into contacting miners, there's a good chance there's going to be someone who doesn't. So we want to take that into account when we plan out everything.
Yeah, I want to take this opportunity to kind of plug the amount of effort we put into getting people aware of upgrades like way in advance, and like how much effort we put into planning this sort of stuff. I mean, geez, 6 months before we start putting out messages and telling people, hey, there's going to be an upgrade, get ready, and we try to make sure that the software is plenty ready to go at least 3 months in advance, and that a lot of testing is happening and this sort of stuff. So we try to put out the message as much as we can, and we try to test as much as we can to make sure it's smooth for everyone. Yeah.
All right. Any further comments on the upgrade?
Yeah. So we had an interesting case with the block that was mined from the original chain, the unupgraded chain, that actually had a really interesting like race condition that happened because we track all the forks that are compatible. So when there's an orphaned block or anything like that, we actually try to sync that and maintain it. There was a really nasty, crazy race condition with how we do our threading with when we received that kind of orphaned block that stalled one of our nodes, and it took me like a week to debug it and then fix it. But it was just something I just wanted to comment on. We ended up fixing it and finding out the thing. It was actually just fortunate that it happened though, so that was the only way that we were even able to discover it. It was purely like a timing issue. But yeah, everything else went great.
Good, thanks, Josh. If there's no further comments on the upgrade, we'll move on to some next upgrade preparedness and discussion of the potential items. We have SigChecks at the top of the list. So who would like to speak to that?
Oh, well, it's too bad Mark's not here because he's working on that. I can describe what it is. So yeah, Mark is basically has started looking on basically improving the way that signature, like right now, when you calculate a signature, validate a signature, it takes a lot more computation than most of the other opcodes, like by a significant amount. So right now there's it's called SigOps, and it basically kind of counts up how many signature checks you do, but it doesn't really count how many you actually do. And then it also has the way that the amount is tracked is also a bit weird because it's per megabyte. So like as soon as it's per megabyte of actual block size, so if the block is like 1.1 megabytes, you have double the amount allowed than if it's like 0.9, for example. Anyway, Mark is working on basically doing a new way of counting how many are actually like computed in a block and making a limit that makes more sense. Yeah, like I said, that's kind of like the overview of it. I won't go. Unfortunately, Mark's not here. I don't know if anyone else wants to comment more on any details of it, but he started working on it. So
I'm happy to comment on it because it's
sure.
So the SigOp counting thing is so. I think this is not even a controversial opinion. It is so currently convoluted and a mess because it's like very heuristical but anyway, it's so complicated that we are like opting out of ever implementing it as it stands because it is such a disaster. So having Mark working on a system that is in any way, shape or form better is really amazing to hear. So we really love an improvement to that. And then the commenting on the purpose and the history of why the SigOp counting existed, I think you did a pretty good job of already covering it, but it's also just to basically mitigate like a poison block, which are much more expensive now than they ever were, but they still something that we should account for. So imagine just a block that just verifies just a massive like amount of transactions or transactions that just have verify signature, verify signature, verify signature, verify signature. All of the other nodes would have to execute that. And at the very end, it might be invalid. And it basically just gives other miners the opportunity to kind of like manipulate the network and guarantee or provide themselves an edge on the other miners. So that's like that's why it exists. So it's not like something that we should just straight up remove. But it is great that we are having someone like Mark who's really smart come up with a better algorithm for how to prevent that. So just wanted to
Is this going to be done? Is this going to be done in a way where it's going to be like compatible with all the old blocks in so that like we don't need to maintain two code paths going forward? Does anyone know?
I'm not actually sure because I don't think Mark has proposed anything concrete yet.
Okay.
No, he's definitely like that's definitely the plan. And then I'm not sure exactly where that stands, but yeah, he's definitely like looked at all the old blocks and calculated, like run the new way of counting it with old blocks and stuff like that. So it's definitely like it's definitely the goal. I'm not 100% sure if that's like if that's able to be done that way. I think it is though.
Okay.
Yeah, let's put it this way. That was discussed in the past, so I know Mark's aware of it.
Okay, good. Well, we'll look forward to Mark being in the next meeting.
Yes. The other nice thing, getting back to what Chris was saying, that's just kind of a side effect of it. Like right now with object data sig, we can't actually like if the reason we can't enable it for like remove the activation and pretend it always existed is because of SigOps counting, because there are historical blocks where that opcode exists in unexecuted if branches. So that's kind of like a weird edge case kind of thing where like and then it exceeds the SigOps limit because of that. So that's kind of like a weird thing. Like there's no reason you should count signature operations in unexecuted branches. So hopefully with the new system, I expect that should go away, and then we can remove the code path for the check data sig activation. So that will be nice. Anyway, that's just a side note.
Thank you, Antony. If there's no further comment on that, we'll move on to the script system. And I think Tobias is going to be speaking to this. Is that correct?
Yeah, so in the last staff meeting, it was briefly touched whether to raise the stack item size limit and the maximum opcode limit for a transaction. And I think it's a good time to raise those limits in the next upgrade. The reasoning behind that is that while I'm developing smart contracts for Be.Cash, I I often run into these limits, and then I have to do all sorts of optimizations to cut that limit down, which often results in having like a larger transaction size. And often it's just unavoidable to it's just impossible to write a script that has the same capabilities but less opcodes. And also, if we want to get more people to write smart contracts, then I think it would be better to like have a more lenient limit, so it's easier for people to get into the system with CashScript, which produces a slightly less efficient code, but which has to be paid for. And also, if you like one objection that could be made to raising the limit would be that it could create a DOS vector. But I think given that we can have many inputs that all have this limit, this opcode limit separately, then you could create the same DOS vector even with a tighter limit. So I'm not in favor of like going full BSV, like removing it and just doing whatever you want, but maybe like having a 500 opcode limit, I think would have the same level of security as currently, and maybe having a 1000 byte stack item limit would be something that would be very helpful for script developers while not sacrificing any security. Any like objections to that or any concerns?
Well, I do have some questions kind of related to bringing some numbers to light. Like, so have you thought about like exact use cases that would benefit from a scripting limit increase? Do you know like roughly how many opcodes we're looking at? Like who's going to be utilizing this? You know, how many users or businesses are affected by this sort of thing? Knowing these ahead of time, like definitely allows us to perceive like how much impact on the system it's going to be making.
Yes, so I haven't asked any other company because I don't think there are currently a lot of businesses that use extensive and large scripts or smart contracts, but I've certainly run into them, and we have like emergent reasons with I've spoken with them and they've run into these two limits already, and they obviously also do optimizations that are are increasing the inefficiency, but like work within those limits. Yeah, I think that this is a very new space, so we only have those two examples. But for those two, it's like actually very painful. So I think it's like if we wait like maybe 5 years, then there might be a couple of more businesses, but it will severely suppress the amount of innovation in that area while those limits are so tight, I think.
So I just noticed that someone typed a question in the Q&A that says, "What's the current opcode limit?" Maybe you can answer that.
Yeah, it's 201.
201. Yeah.
Yes, so I currently have a smart contract lying around that uses 288 opcodes, and no matter what I do, I can't get it down without like ripping the whole use case. So yeah, it's hard to get around the limit.
Well, I guess could you elaborate on that use case? I still don't have a good idea of what it is you're trying to do.
Yeah, so Chris, did you want to say anything?
Yeah, this is due to like all the parsing of the covenant code, right? Like when you have to parse apart the transaction and everything like that's eating up a lot of the opcodes. Is that right?
No, actually parsing the yeah, the pre-image of the what's getting signed, it doesn't take a lot of opcodes. It takes like 10 opcodes, something like that. The worst part is actually SLP. So SLP uses big endian numbers, and to convert, everything in script only uses little endian numbers. So to convert, like do any kind of math with an SLP, you have to convert the numbers first to little endian using num to bin, and then convert it using like byte shuffling, cat and split to reverse the order of the bytes, and that takes like 4 bytes per 4 opcodes per byte -1, something like that. Yeah, and if you do like 2 conversions, that's already like 30 opcodes. And
yeah, I'm just wondering if there would be like a way, you know, like if it might be a better way is to introduce like opcodes for like the specific cases rather than just raise the limit. But.
Yeah, I proposed OP reverse, which would like reduce this to like a constant number of opcodes, like 1 opcode, or like maybe 2, because convert and reverse. And Mark Lundberg was kind of supportive of the idea, but it was like, hey, this is very specific to SLP. So it's a very, very simple opcode. I think it could be implemented very quickly. But it feels kind of not fitting into like the whole script system. And yeah, so I thought it was easier to be like, okay, let's just raise the limit so we can have all these use cases without having to define a spec and having to go back and forth between all the like how to define this opcode. And as I said, I don't think the opcode, if the limit is like doubled or so, it will like if it's halved, it doesn't prevent any DOS attacks or any kind of attacks, in my opinion.
Yeah, I think like personally, just the way I like, one thing I've been thinking about for a long time is it would be nice to have some kind of like overall essentially goal or plan of what we're trying to do with the script system. Because yeah, like Chris mentioned, it's like sometimes there's like multiple ways of like if you find you're doing something that over and over really inefficiently, then it seems a bit unfortunate. Like it seems kind of like, well, it's not ideal. But yeah, like this, because there's a whole bunch of different things in there, like having bigger numbers and having optimal, and there's things that interact with each other too. So not this specifically necessarily, but say like, you know, say we wanted bigger numbers, that affects maybe how optimal would behave, or for example, and how you handle overflows and stuff like that. So yeah, I mean, this is kind of not directly related to what you're talking about, but I think it would be nice if someone or a bunch of people tried to like write down what's kind of like, where are we going, where are we aiming at with these changes to the script system, and come up with something where like everything fits together. And there's multiple levels to that too, because you proposed your Nimbus, Tobias, which is kind of like a whole new thing, as far as I understand it. Whereas like adding a few opcodes and like maybe making bigger integers, just in the current script system seems that's a bit less ambitious, but that might also like be something, like come up with a plan for that, like the less ambitious kind of changes. Anyway, yeah, it's kind of like not totally related to what you're saying with raising the limit, but I think that's like a worthwhile thing to do in general for all this stuff.
Yeah, but it does make sense to be like, okay, we like clearly there might be some inefficiencies that are just inherent in a current script system, and raising the limit just like increases those or like perpetuates those inefficiencies without actually addressing the core problems. So raising the opcode limit, I think it should be done anyway, regardless of if we have more efficient opcodes that allow some use case like that. But what you say is totally valid. It's like, okay, you need to have like bigger numbers, because that's also a big drawback, because we only can handle like 31-bit 8-bit numbers if we want to go unsigned. And that allows only so big of Satoshi amounts to be calculated with, which also makes validation of contracts much harder, especially if you use like truncating to get to higher amounts. But yeah, and Mark Lundeberg talked about how we could get bigger numbers with like, yeah, I don't remember his proposal exactly, but he had something very simple, and I think yeah, it would be cool if we could discuss this here, but he doesn't seem present. Yeah, but what do you think about like raising the opcode limit to get these additional use cases?
Personally, I mean, I don't know. I don't have a strong opinion one way or the other. Personally, I just feel like, yeah, I don't know. I mean, I think it would have to be like, you know, make look and like, I don't know, kind of make a good case for it and look at the potential downsides and so on. Yeah, I don't know. Personally, I kind of want to have a feeling like we know, like we have an overall plan of what's going on with the script system. But that's just that. But yeah, I don't have a strong opinion in this case.
Like, I guess I'll be the guy that is kind of like, you know, and kind of worried about unforeseen consequences and looking at alternative solutions. So I do have a couple questions. So one, it sounds like some of the issue revolves around SLP using big endian. So if SLP didn't use big endian, you know, would that cut down on the number of opcodes that you need in order to write a transaction within the current limits? And like, I'm wondering, like, what are the use cases of an op reverse if big endian is out of the picture? And then another question, which might be a little harder to swallow because I know SLP's already been deployed for some time, but if SLP 2.0 was designed to work better with the script system, does this problem kind of disappear?
Yep. So the first part is, yeah, it was 3 questions. What was the first question again?
Sorry.
Something SLP.
Well, so if SLP didn't have any issues with big endian, would that cut down the number of opcodes?
Yeah. Oh, yeah. True. That was the question. Yeah. Yeah. So yeah, currently there's a lot. I think around 50 to 60 opcodes, maybe in that realm, that gets eaten up by endianness conversion. So I mean, there's still a large chunk. So even if that could be reduced to 0, it still wouldn't fit in the 201 opcode limit, because I'm also doing a Merkle proof for another use case. And those, like, they are already very efficient. So one layer of a Merkle proof only takes 5 bytes, 5 opcodes. I think that's as small as it could get. So yeah, it's just that this smart contract is particularly complicated for the use case I'm doing, and like, yeah, I think that's like 20% or so, or maybe a bit more, is eaten up by SLP conversion. Yeah, the second question you had was if op reverse has any other use case. I've proposed op reverse and then like removed it again, because that was like the main issue. Like, okay, we couldn't find any other use case. I think the only thing was, okay, we can check if it's a palindrome or something like that. So it's pretty useless otherwise. And also the op reverse doesn't handle. I think it handles signedness, but it didn't pay too close attention if the sign bit is actually properly handled. I think it is, but yeah. So other than endianness, it doesn't seem very, very useful. Also, the endianness is actually kind of important, because what if you have a third-party source that only produces big endian numbers for an oracle, then that might be useful. But other than SLP, that's not very useful. And for changing SLP, for a new version, I would be very much in favor of keeping all the endianness in the whole Bitcoin to a little endian, because like that's what we stuck to, and I think we should keep it. And yeah, maybe it might be a idea to be like, okay, let's add a hard fork for SLP that also allows the little endian numbers. I mean, that would be kind of messy, but if the use case is that strong, then maybe people will agree to upgrade the rules. But I don't see it happening too much.
Related to the opcode limit stuff, so something to add. There was a little bit of good discussion in September on the Bitcoin dev mailing list about some of the script limits. Here's a link, I just stick it in the chat. One thing that's worth noting related is for the opcode limit specifically, the opcode limit could be like well into the thousands, and it wouldn't really have any meaningful effect on the execution time of programs, with the exception of the participating public keys in a check multisig, I think, is like the only meaningful constraint that the opcode limit actually adds. So there might be probably a slightly better heuristic than kind of the rough opcode limit thing, especially the counting it non-executed branches and stuff, where if we switched away from the 201 limit to doing the SigChecks limit that Muhlenberg is working on right now, or something like that we would be able to have an opcode limit well into the thousands and it wouldn't matter at all. So it may be part of the same discussion, actually. But there's some good info. There was some good discussion on the mailing list there, and I don't forget where else I saw other things at IRC and stuff.
Yeah, I want to point out that they're definitely interrelated. Like being cognizant of all of these limits while trying to raise even just one of them is very important. So that's kind of why Antony and I had been pointing out earlier, like seeing more analysis done on what it means to be raising one limit or the other is pretty important, because knowing how they interplay is going to be difficult in some cases. So having a good understanding, it's good to see that someone's already written something about it. I need to go read it. I haven't seen this. But it is good to hear that there's at least some idea that it may be safe to bump it to some degree.
Yeah, I need to dig around. There was like a Bitcoin talk thread in like 2013 or 2014 also that I recall, where Mike Hearn and some of them were talking about getting rid of the limits and replacing them with a thinner, easier to manage heuristic. But so maybe I can dig that up too. But yeah, the thinking has actually been done quite a bit, maybe like 5 years ago too, that we should probably dig up.
I have some thoughts too. So firstly, I wanted to start by saying kudos to Jason and Antony, because I think it's really important that we as like protocol, when we discuss changing the protocol, it should really be driven by actual demand. And making sure that businesses are seeing a real benefit from any change that we apply to the protocol itself. So ensuring that it's not just Tobias that benefits from this change, I think is really valuable. And in response to that, I think it would be really beneficial if Tobias as a next step goes and actually puts together a motivation statement for why this is useful and who else can benefit from it. I think with that, I think it would be really hard to argue against not considering this as a thing for the next upgrade, and that also kind of forces the rest of the community to really explain why why we wouldn't want to increase the limit, instead of just saying, oh, we talked about it previously. So I think that would be kind of a really nice next set of steps. And then I personally remember that we talked about this a little bit, maybe in Australia or maybe at the last dev meeting or somewhere in Telegram. But I think generally, everyone agrees that it's not terribly risky, especially with the things that was just brought up with like the opcode or the sig checking, the sig count checking and stuff like that. So I don't know. I just want to propose like something that we can actually do about it. So if you know, if that sounds reasonable, maybe that's the procedure that we can go with going forward.
Yeah, I guess all of our past comments didn't really provide an action item, but Tobias, if you can write up something that breaks down the problem, you know, give us an example. Show us, hey, here's the transaction I'm trying to build. It requires this many opcodes, and explore different areas with different assumptions. Say, you know, like if SLP didn't have big endian, here's how big it would be, and here's what I would need, and you know, make those assumptions more and more extreme, and then we can kind of figure out, okay, like where in this universe are we able to make the largest gains with the smallest amount of change to the protocol, because those tend to be the kind of improvements that are easier to make in an upgrade.
Yeah, that makes sense. I already planned writing something up, but then this meeting came, so I was like, okay, let's go here first.
Well, you may get a chance before the end of the year. We may have another meeting coming up towards the end of December. We have a few links that have come in, and I just want to encourage you all to any background information on this subject. If you want to bring forward links, you can do that here in the Telegram group, and we'll include those with the with the show notes, and then have them ready for the next meeting, hopefully in a couple of weeks. Is there any further discussion on the CashScript? Oh, sorry, the script system?
Has anybody done any further work on an opcode to push pre-image data, signing serialization pre-image data? Other than, we had discussed it in this group, in the Telegram group a couple weeks ago, but I've not seen a gist or anything from anybody, any proposals or stuff. Any work been done there? No, probably not.
Everybody's
cool.
Yeah, I haven't, obviously, but I will also voice my support for such a concept, and also will say that from Bitcoin Verde's perspective, it would be super easy for us to implement.
Yeah.
So I know that obviously affects like what gets done in what time frame, but from our perspective, it's not a difficult thing to do. So if someone wants to make that their priority, I think that would be super cool.
I might try to put together a specification for that. Yeah, I just wanted to make sure nobody else has already started on it.
It may be that Mark. It may be that Mark has, but we won't know that until he's available again.
No one's done anything on that other than talk about the idea and concept.
Okay.
But yeah, I mean, it's a good idea. But yeah, it kind of fits into what I mean, maybe I'll just try to compile. I might just try to put together a document that essentially compiles a list of all these different ideas, and because I basically just want to have more information about everything and how it all fits together, because there's a lot of like good ideas. Cool. That's one of them. So.
Yeah, I think one reason for this change would be to make the transactions more compact and more efficient. Because currently, like, you have to put the script code twice into the transaction and put the outputs twice in there. So the way I thought about it would be like, okay, yeah, let's have maybe an opcode that has like multiple variants that can check different parts of the pre-image. Then that would be more tailor-made and not be like this crude solution that just captures everything. But I think it would be best to somebody write something up and then people like comment on that and be like, oh, yeah, let's change this, let's change that.
Yeah, I mean, the current system basically ties it to to the current SigHash algorithm, for example. So like if you wanted to change the SigHash algorithm, then that would break all this. Like you couldn't have a different SigHash, it would break all the scripts that rely on that, for example. But like pushing elements of the transaction onto the stack maybe would be more robust to that kind of thing. Anyway, yeah, there's like lots of different, like we kind of said, lots of different.
And it would reduce the number of SIG operations, which
Yeah,
would also be good for the network in general.
So Tobias, this is also back to your up reverse. Are there other, like, do you think that's something that would have a lot of other use cases other than just the SLP thing? And I guess that also ties
up reverse in particular.
Yeah.
As I said, the only 2 use cases, like 3 if you count checking for palindrome, which I don't think is a use case, is getting like a first SLP, and second hooking into oracles that only support big endian for some reason. Maybe it interacts with some other chain or other system, and it like more or less is forced to use big endian. Then that would also be an advantage of OP reverse.
Yeah, because the other thing, I haven't thought about this very much, so maybe this doesn't make sense, but if you went to bigger numbers, like bigger integers, you'd also want to make sure that works.
Yeah, because there's been a proposal, like we talked about that just a minute ago, to have bigger numbers. And that would also benefit SLP, because then you can use like all decimal places of tokens and not like artificially restrict the like the number of decimal places you want to use, because you run into these limits. But that obviously would exponentially increase the number, the size. Okay, not exponentially, linearly increase the size of the scripts to convert little endian to big endian. So if we were to increase the numbers, then we would also see a large increase in the opcodes, like in a number of opcodes of a script that uses SLP, if we don't have something like OP reverse. So it might be like, okay, let's just add OP reverse to like solve like these 2 issues, and because it's not a big change, it might be like, okay, let's just add it.
Anyway, I think I've asked enough questions for right now. Thanks, Tobias.
Does anyone else have any further questions for Tobias? Hearing none, I think we'll move on to the final item on our agenda, which is just a quick comment from myself. It's a fairly big deal. It's getting a tremendous amount of support from the entire community, development community, and I want to thank Josh Green for heading this up, and that is the BCH specification update, or specification project, and we're looking for an update. Josh, can you give us a bit of an update on what's going on?
Yeah, absolutely. Firstly, I'm really happy that the community does support this project. I also want to like thank BU too, because the only reason this is really happening is because they're funding our work for this. So like legitimately, I think that's a really awesome thing for them to be able to do. So the update for the project is we've been working on it since about like the 2nd or so. We have like kind of like a backbone or a layout of what the documentation like pages will look like and the organization of them. It's designed to be what is the current state of the protocol. So currently right now, like if you want to figure out what the protocol does, you either have to look at the source code or you have to like go through a series of BIPs to see how one might modify the other, and then just like kind of apply them in your head sequentially if they're related. That's, that makes sense because of the way that we've been developing things, but if you're new to the space or if you don't have a perfect memory, like I don't, or most of the world doesn't, then you kind of want a document that says, this is how it works currently. And that's what we're trying to provide. What we are architecting is basically a way for us to say, this is what the protocol itself does. This isn't what a node specific does. So what we are doing is saying, this is the super majority of what all of the nodes do. And this is what we are considering like the default behavior. And then for each section that we're documenting, we have another like subsection that says, if ABC does something different, or if Bitcoin Verde does something different, or if BU does something different, That's basically like scratch space that the node implementations themselves can put in their 2 cents, as long as it's objective and factual. That is just a single source for anybody that is either a protocol developer or a script developer, or anybody who just wants to interface with the protocol. That's a place for them to go look. We've been using a lot of existing documentation to kind of give us a jump start. We are not intending on having the whole thing done in a month. That would be ridiculously impossible, but we are making a lot of good progress. The other decisions that have been made is the platform in which it is originally or initially being hosted and distributed. So there is a tool called SigChecks, which is basically, it tries to be like a wiki, but instead of saving to a database, it saves to a bunch of MD files, so markdown files. And you write the content that you want displayed in Markdown, similar to how you would do in a wiki. There's like a little WYSIWYG for formatting and stuff. And then when you save it, though, it gets committed to an MD file. And then these MD files get committed to a Git repo where each user that wants to make changes to the wiki has their own kind of like branch too. And then these branches get merged, and everyone can see these changes and apply them. And it also prevents people from going through and doing a bunch of stuff that we wouldn't want them to do, and then having it be a really big pain in the butt for us to undo it. We basically just leveraging Git to handle all the heavy lifting for us. It's also heavily forkable because the data itself is in a Git, so it'll be a public Git. And if a different entity wants to fork the content and then host their own version, they absolutely can. We won't and can't stop them. And that's also true for the node implementations themselves. So if one node implementation happens to disagree with the direction of the project, they can clone it and then host their own. For instance, so we're proposing that there will be a single release coming up of where you can go and contribute. We don't know the domain for it yet. It'll either be like development cache or Bitcoin protocol.cache or some other ones that we've been tossing around. But we're also hoping that the other node implementations will clone and host their own version as well. So for instance, I can speak for Bitcoin Verde. We would like to clone the whatever content we have, and then have a protocol.bitcoinverde.org copy of that. And if for whatever reason Bitcoin Verde happens to disagree with the direction of the spec, we can just host our own copy with whatever slight modifications that we want. It also allows, if everyone plays nicely, it kind of incentivizes people to collaborate instead of disagree, because ideally there's a lot of work in maintaining the protocol. So if you diverge too much, you're going to have to start doing a lot of those updates yourself, and then if you don't put in that effort, you're going to fall behind the rest of the community, and people are going to start devaluing your documentation. So there's an incentive to use the central one, but you have the power to have your own and disagree. Even the centralized one, we're doing as much as we can to keep it as decentralized as possible. So we're trying to use the minority implementations to have as much control, I guess, over, or ownership of the components. So Bitcoin Verde / Software Verde is going to own the domain, and then BCHD is owning the server. It disincentivizes Bitcoin Verde from saying we own the spec and because we own the thing or whatever. We're trying to keep things as distributed and dependent upon one another as possible, while ultimately still allowing everybody the flexibility to do whatever they want. So that's the overall structure of things. We're making pretty good progress on the actual content. And finally, the thing that we're focusing on currently is just documenting the most contentious, but also not overly complicated feature across the different nodes, which we found to be the services bit flag and the version message. So after a very, very small amount of research, we realized that every node basically handles that differently. So we are documenting that first, and we're hoping to have each implementation have an opportunity to see how we are handling it, and then give them the opportunity to further document their slight nuances to that particular feature, which sets the precedent for how contentious behavior is handled for the rest of the spec. So I'm happy to answer questions. And yeah.
Thanks for that overview, Josh. And I'm sure there will be questions and comments. So anybody like to have a go? Maybe I'm wrong. No question.
You told me the 1 month wouldn't be enough to do the whole thing. What's your like ETA for the spec, or do you plan to release it in like slices, or do you want to be like, okay, we'll work on this for 3 months and then here we go?
Yeah, no, that's an awesome question. So the way that it's contracted right now with BU is they just purchased like a bank of hours. So technically Software Verde is the entity writing the spec, not necessarily Bitcoin Verde, but we're like the same people. So, so it's literally just a regular contract that we have with them. Once that bank of hours runs out, they mentioned the possibility of doing follow-up sponsorship, which I think would be really cool. And we've also talked with Emergent Reasons and some other people about perhaps seeking sponsorship from other entities to kind of get the rest of it done. I'm hoping that I'm hoping that we get enough done in the month worth of hours that we can kind of inspire other people to start contributing. And that's actually one of our goals in the short term, is to start opening up the actual like current version to select people of the like development community so that they can start working in parallel. Those people currently that have nominated themselves is like Josh Ellithorpe, Mark Lundeberg, I think Emergent Reasons, and somebody else, I don't even remember. Like a bunch of people were like, hey, like we have some time, we'll throw in some contribution hours into documenting it. And the important thing from our perspective is once we get enough of a precedent set, we get enough precedent set, it'll like kind of preemptively calm any issues that we know we're going to have regarding disagreements with how things are handled. So that's why we haven't released it currently, and it's because we want to have like a style guide, we want to have like a code of conduct, we want to have a contentious precedent set for how things are done, and we also want to have a template page done so that when Tobias goes in or Tobias goes in and says, I want to document this particular opcode, he's not completely lost in the sauce and has, kind of like a template to work from. So these are the things that we want to have established before we say, okay, everyone go wild. We have to get there first. It's only been like a week or so. And then following up with either, people's free contributions, which may include our hours as well, just after this, or follow-up sponsorship from either BU or Bitmain or whoever else wants to sponsor the work. So, let me know if that doesn't answer your question.
So 2 weeks.
2 weeks what?
No, it was a joke.
Oh yeah, we'll have the whole thing done in 2 weeks. Yeah, you can have me on record right now.
Sure.
No,
that's a great start, Josh. Anybody have any further questions for Josh Green on the BC8 specification project? Okay. Does anyone have anything that they want to speak to within this meeting before we wrap up? No further comments? No further updates? Well, I'd like to thank you all for attending today and look forward to meeting again soon, and we'll chat in the near future. So thank you very much today.
Thanks. Bye bye, everyone.
Thank you.
See you.
Bye bye.